Introduction to Software Engineering Fundamentals. In this video, we are going to see about Introduction to Software Engineering Fundamentals. Software engineering is the study and an application of engineering to the design, development, implementation, and maintenance of software in a systematic method. Software engineering is an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. The outcome of software engineering is an efficient and reliable software product. IEEE defines software engineering as the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software, that is, the application of engineering to software. Software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and work efficiently on real machines. Software is more than just a program code. A program is an executable code which serves some computational purpose. Software is considered to be a collection of executable programming code, associated libraries, and documentations. Software, when made for a specific requirement, is called software product. Engineering, on the other hand, is all about developing products using well-defined scientific principles and methods. Definition of software product and process. In this animated video, we are going to see about definition of software product and process. Software product. What is delivered to the customer is called a product. It may include source code, specification document, manuals, documentation, etc. Basically, it is nothing but a set of deliverables only. A software process defines the approach that is taken as software is engineered, but software engineering also encompasses technologies that populate the process, technical methods, and automated tools. Software engineering is performed by creative, knowledgeable people who should work within a defined and mature software process that is appropriate for the products they build and the demands of their marketplace. Software process. Process is the way in which we produce software. It is the collection of activities that leads to a part of a product. An efficient process is required to produce good quality products. Who does it? Software engineers, project managers, and customers. Why is it important? It provides stability, control, and organization to an activity that can, if left uncontrolled, become quite chaotic. What are the steps? The process that you adopt depends on the software you are building. What is the work product? The work products are the programs, documents, and data produced as a consequence of the software engineering activities defined by the process. Software process can be categorized into 4 major types of component processes as given below. Software development process, software project management process, software configuration management process, Software process management. Software development process is a structured set of activities that transform the user requirements into a quality software product. Planning and scheduling of tasks and monitoring their execution fall in the domain of project management process. Development processes generally do not focus on evolution and changes. To handle these, another process is used which is called software configuration management process. The objective of this process is primarily to deal with managing changes in software requirements and its environment. An organization needs to keep improving to remain competitive. Hence, to enhance its capabilities, an organization must adopt a process by systematically reviewing and improving all its processes. The process of understanding the current process, analyzing its properties, determining how to improve, and then effecting the improvement is dealt with by the process management process. The basic objective of the process management process is to improve the software processes. It provides the framework from which a comprehensive plan for software development can be established. If the process is weak, the end product will undoubtedly suffer. There are many lifecycle models and process improvements models. Depending on the type of project, a suitable model is to be selected. Nowadays, CMM, that is, Capability Maturity Model, has become almost a standard for process framework. Software characteristics. In this video, we are going to see about software characteristics. While developing any kind of software product, the first question in any developer's mind is, what are the qualities that a good software should have? Well, before going into technical characteristics, I would like to state the obvious expectations one has from any software. First and foremost, a software product must meet all the requirements of the customer or end user. Also, the cost of developing and maintaining the software should be low. The development of software should be completed in the specified time frame. Well, these were the obvious things which are expected from any project, and software development is a project in itself. Now, let's take a look at software quality factors. These set of factors can be easily explained by software quality triangle. The three characteristics of good application software are operational characteristics, transition characteristics, revision characteristics. A software product can be judged by what it offers and how well it can be used. This is because they are involved with the software in different ways. Functionality. Performance of the software against its intended purpose. Reliability. Ability of the software to provide desired functionality under given conditions. Usability. Extent to which the software can be used with ease. Efficiency. Ability of the software to use system resources in the most effective and efficient manner. Maintainability. Modifications can be made in a software system to extend its functionality, improve its performance, or correct errors. Portability. Transfer software from one platform to another without or with minimum changes. robustness. Keep on functioning. Transition characteristics of the software. Interoperability, reusability, portability. Software components. A component is an independent software unit that can be composed with other components to create a software system. Council and Heinemann define a component as a software element that conforms to a component model and can be independently deployed and composed without modification accordingly to a composition standard. Important components of software engineering are software development lifecycle, that is SDLC, software quality assurance, software project management, software management, computer-aided software engineering, that is CASE case. Software applications. An application program is a computer program designed to perform a group of coordinated functions, tasks, or activities for the benefit of the user. Examples of an application include a word processor, a spreadsheet, an accounting application, a web browser, a media player, an aeronautical flight simulator, a console game, or a photo editor. The collective noun application software refers to all applications collectively. This contrasts with system software, which is mainly involved with running the computer. Layered technologies. In this video, we are going to see about layered technologies. Layered technology is divided into 4 layers: quality, process, methods, tools. Quality. A product should meet its specification. This is problematical for software systems. There is a tension between customer quality requirements, that is efficiency, reliability, etc., developer quality requirements, that is maintainability, reusability, etc., users, that is usability, efficiency, etc. Some quality requirements are difficult to specify in an unambiguous way. Software specifications are usually incomplete and often inconsistent. Process. The foundation for software engineering is the process layer. Software engineering process is the glue that holds the technology together and enables rational and timely development of computer software. The work products are produced, milestones are established, quality ensured, and changes are properly managed. Methods. Method encompass a broad array of tasks that include the requirement analysis, design, program construction, testing, and support. Tools. Software engineering tools provide automated or semi-automated supports for the process and the methods. CASE combine software, hardware, and software engineering database. Generic view of software engineering. In this video, we are going to see about generic view of software engineering. The work associated with software engineering can be categorized into 3 generic phases, regardless of application area, project size, or complexity. Definition phase, development phase, support phase. Software crisis. In this video, we are going to see about software crisis. The software crisis has been with us since 1970s. As per the latest IBM report, 31% of the projects get cancelled before they are completed, 53% overrun their cost estimates by an average of 189%, and for every 100 projects, there are 94 restarts. When software is developing, then during development, many problems are raised up. That set of problems is known as software crisis. When software is developing, then on the different steps of development, problems are encountered associated with those steps. Now we will discuss the problem and causes of software crisis encounter on different stages of software development. Problems. Schedule and cost estimates are often grossly inaccurate. The productivity of software people has not kept pace with the demand for their services. The quality of software is sometimes less than adequate. With no solid indication of productivity, we can't accurately evaluate the efficiency of new tools, methods, or standards. Communication between customer and software developer is often poor. The software maintenance task devours the majority of all software rupees. Causes. Quality of software is not good because most of the developer use the historical data to develop the software. If there is delay in any process or stage, that is analysis, design, coding and testing, then scheduling does not match with the actual timing. Communication between managers and customers, software developers, support staff, etc. can break down because the special characteristics of software and the problems associated with its development are misunderstood. The software people responsible for tapping that potential often change when it is discussed and resist change when it is introduced. Software crisis in the programmer's point of view. Problem of compatibility. Problem of portability. Problem in documentation. Problem of piracy of software. Problem in coordination of work of different people. Problem of maintenance in proper manner. Software crisis in the user's point of view. Software cost is very high. Customers are moody or choosy. Hardware goes very down. Lack of specialization in development. Problem of different versions of software. Problem of use. Problem of bugs. Software development paradigms. In this video, we are going to see about software development paradigms. A paradigm is the model of a process. It defines the flow of activities that occur as the process progresses from start to end. In the context of software engineering, a paradigm provides a framework that identifies major activities, sometimes called phases, detailed work tasks, milestones, and deliverables. A number of different paradigms can be applied during a software project. These will be discussed in this ESE module. Essential software engineering. Planning. Risk assessment. Engineering. Installation. Customer evaluation. Management and technical tasks are defined for each of the task regions. To accommodate the need for an adaptive process, for example, one that adapts itself to the characteristics of the project at hand, the evolutionary model should define a number of task sets. Each task set contains software engineering tasks, milestones, and deliverables that have been chosen to meet the needs of different types of projects. Each task set must provide enough discipline to achieve high software quality, but at the same time, it must not burden the project team with unnecessary work. Although any number of task sets can be suggested, the following are typical: casual, disciplined, rigorous, quick reaction. Some suggested adaptation criteria follows: size of project, number of potential clients or customers, business criticality, longevity, stability of requirements, ease of customer-developer communication, maturity of technology, performance constraints, hardware and software environment. Techniques of process modeling. In this video, we are going to see about techniques of process modeling. A system too large for one person to build is usually also too large to build without an overall plan that coordinates the people working on it, the tasks that need to be done, and the artifacts that are produced. Researchers and practitioners have identified a number of software development process models for this coordination. Here are some of the main ones. These process models are alternatives but not exclusive ones. Most describes different aspects of a process, and it is common for a development group to be followed two or more simultaneously. For example, the sashimi process is a way of organizing a waterfall with feedback. Boehm's spiral model example uses prototyping as the model for each cycle and portions of a waterfall model for the delivered system stage of the prototyping model. An incremental process often uses a sashimi process for its produce a build stage. Techniques of process models are code and fix, sequential processes, waterfall, sashimi, prototyping, cyclical processes, spiral, unified, incremental, agile, scrum, test-driven, extreme programming. Software process and lifecycle models. In this video, we are going to see about software process and lifecycle models. A software lifecycle model is a standardized format for planning, organizing, and running a new development project. Hundreds of different kinds of models are known and used. Many are minor variations on just a small number of basic models. In this section, we survey the main types of model, consider how to choose between them. A software or system lifecycle model is a description of the sequence of activities carried out in an SE project and the relative order of these activities. It provides a fixed generic framework that can be tailored to a specific project. Project-specific parameters will include size in person years, budget, duration. Build and fix model. In this video, we are going to see about build and fix model. The build and fix model was adopted from an earlier and simpler age of hardware product development. Those who bought early Volkswagen automobiles in the 1950s and 60s remember it well. As new models were brought out and old models updated, the cars were sold apparently without benefit of testing, only to be tested by the customer. In every case, the vehicles were promptly and cheerfully repaired by the dealer at no cost to their owners except for the inconvenience and occasional risk of a breakdown. This method clearly works, but it depends on having a faithful and patient customer set, almost totally dependent on the use of your product. It is the same with software. A few well-known vendors are famous for their numerous free upgrades and the rapid proliferation of new versions. This always works best in a monopolistic or semi-monopolistic environment in which the customer has limited access to alternative vendors. Unfortunately, in the build and fix approach, the product's overall quality is never really addressed, even though some of the development issues are ultimately corrected. Also, there is no way to feed back to the design process any proactive improvement approaches. Corrections are put back into the market as bug fixes, service packs, or upgrades as soon as possible as a means of marketing damage control. However, the model is perhaps still the approach most widely used by software developers today, as many will readily and somewhat shamefully admit. The Waterfall Lifecycle Model. In this video, we are going to see about the Waterfall Lifecycle Model. The Waterfall Model, also called as Phased Lifecycle Model or Waterfall Chart, or the oldest model or the classic life cycle, suggests a systematic sequential approach to software development. It begins with customer specification of requirements and progresses through planning, modeling, construction and deployment, concluding in ongoing support of the completed software. The following problems faced when the waterfall model is applied. Real projects rarely follow the sequential form that the model proposes. It is often difficult for the customer to state all requirements explicitly, and the customer must have tolerance. In an interesting analysis of actual projects found that the linear nature of the waterfall model leads to blocking states in which some project team members must wait for other members of the team to complete dependent tasks. It can serve as a useful process model in situations where requirements are fixed and work is to proceed to completion in a linear manner. This takes the fundamental process activities of specification, development, validation, and evolution and represents them as separate process phases such as requirement specification, software design, implementation, testing, and so on. The first published model of the software development process was derived from more general system engineering processes: requirement analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance. Advantages of Waterfall model. The advantages of the Waterfall model are that documentation is produced at each phase and that it fits with other engineering process models. Therefore, the Waterfall model should only be used when the requirements are well understood and unlikely to change radically during system development. Limitations of the Waterfall model. The Waterfall model assumes that the requirements of a system can be frozen before the design begins. Freezing the requirements usually requires choosing the hardware. The Waterfall model stipulates that the requirements be completely specified before the rest of the development can proceed. Prototyping lifecycle model or throwaway prototyping. In this video, we are going to see about prototyping lifecycle model or throwaway prototyping. There are two approaches for prototyping are throwaway and evolutionary. In the throwaway approach, the prototype is constructed with the idea that it will be discarded after the analysis is complete and the final system will be built from scratch. The goal of a prototyping-based development process is to counter the first two limitations of the Waterfall model. The basic idea here is that instead of freezing the requirements before any design or coding can proceed, a throwaway prototype is built to help understand the requirements. This prototype is developed based on the currently known requirements. The process model of the prototyping approach is shown in the figure. A development process using throwaway prototyping typically proceeds as follows. The development of the prototype typically starts when the preliminary version of the requirement specification document has been developed. After the prototype has been developed, the end users and clients are given an opportunity to use the prototype and play with it. Based on the feedback, the initial requirements are modified until to produce the final requirement specification, which is then used to develop the production quality system. Prototyping is often not used as it is feared that development costs may become large. The prototyping focuses on producing software products quickly. Software prototypes are produced with limited functionality and performance to make it possible for developers and clients to check the functions of preliminary implementations of system models before committing to a final system. The prototyping approach solves the waiting problem in the Waterfall model. Prototyping is iterated to obtain feedback from clients and changes in system concepts. Evolutionary development lifecycle model. In this video, we are going to see about evolutionary development lifecycle model. There are two approaches for prototyping are throwaway and evolutionary. In the evolutionary approach, the prototype is built with the idea that it will eventually be converted into the final system. Evolutionary development is based on the idea of developing an initial implementation, exposing this to user comment, and refining it through many versions until an adequate system has been developed. Exploratory development, where the objective of the process is to work with the customer to explore their requirements and deliver a final system. The prototype concentrates on experimenting with the customer requirements that are poorly understood. An evolutionary approach to software development is often more effective than the waterfall approaches in producing systems that meet the immediate needs of customers. The evolutionary approach has two problems. The process is not visible and systems are often poorly structured. The evolutionary SLCM, that is software lifecycle model, consists of planned development of multiple releases of a product. The evolutionary lifecycle model entails continual overlapping of development activities which produce a succession of software releases. The disadvantage of the evolutionary model is that it can be costly if it is assumed that a current release is made with the assumption that it will be succeeded by an improved version of the software later. The spiral lifecycle model. In this video, we are going to see about the spiral lifecycle model. The spiral model is an evolutionary software process model that couples the iterative nature of prototyping with the controlled and systematic aspects of the waterfall model. The spiral development model is a risk-driven process model generator that is used to guide multi-stakeholder concurrent engineering of software-intensive systems. It has two main distinguishing features. One is a cyclic approach for incrementally growing a system's degree of definition and implementation while decreasing its degree of risk. The other is a set of anchor point milestones for ensuring stakeholder commitment to feasible and mutually satisfactory system solutions. The spiral model is a realistic approach to the development of large-scale systems and software. The spiral model demands a direct consideration of technical risk at all stages of the project and, if properly applied, should reduce risks before they become problematic. The risks here are typically whether or not the goals can be met within the constraints. In round 2, the top-level requirements are developed. In succeeding rounds, the actual development may be done. Some of the advantages of the spiral model are: it could be as effectively for system enhancement as for system development. Most lifecycle models can be considered as a special case of the spiral model. The embedded risk analysis built into the model avoids many of the difficulties that arise in other models. The incremental lifecycle model. In this video, we are going to see about the incremental lifecycle model. The incremental model combines elements of the waterfall model applied in an iterative fashion. The incremental model applies linear sequences in a staggered fashion as calendar time progresses. Each linear sequence produces deliverable increments of the software. When an incremental model is used, the first increment is often a core product. The incremental model focuses on the delivery of an operational product with each increment. Incremental development is particularly used when staffing is unavailable for a complete implementation by the business deadline that has been established for the project. Like a disadvantage, the incremental model makes the unrealistic assumption that the system as well as software requirements remain stable. Incremental development refers to the process of developing to completion only a part of the requirements at a time. This approach has been used successfully for business information systems. Developing a large, complex software product using this approach may end to reduce the schedule and make each increment more manageable than taking on the complete product development at one time. Each increment is developed using a waterfall development process. Agile development model. In this video, we are going to see about Agile development model. In software application development, Agile software development, that is ASD, is a methodology for the creative process that anticipates the need for flexibility and applies a level of pragmatism into the delivery of the finished product. Agile software development focuses on keeping code simple, testing often, and delivering functional bits of the application as soon as they are ready. The goal of ASD is to build upon small client-approved parts as the project progresses, as opposed to delivering one large application at the end of the project. Agile software development stated as individuals and interactions over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. Responding to changeover following a plan. A manifesto is normally associated with an emerging political movement, one that attacks the old guard and suggests revolutionary change, hopefully for better. In some ways, that's exactly what Agile development is all about. What is it? Agile software engineering combines a philosophy and a set of development guidelines. The philosophy encourages customer satisfaction and early incremental delivery of software, small, highly motivated project teams, informal methods, minimal software engineering work products, and overall development simplicity. The development guidelines stress delivery over analysis and design, and active and continuous communication between developers and customers. Who does it? Software engineering and other project stakeholders, that is managers, customers, and end users, work together on an agile team, a team that is self-organizing and in control of its own destiny. An agile team fosters communication and collaboration among all who serve on it. Principles of Agile methods. Principle. Description. Customer involvement. Customers should be closely involved throughout the development process. Their role is to provide and prioritize new system requirements and to evaluate the iterations of the system. Incremental delivery. The software is developed in increments with the customer specifying the requirements to be included in each increment. People, not process. The skills of the development team should be recognized and exploited. Team members should be left to develop their own ways of working without prescriptive processes. Embrace change. Expect the system requirements to change and so design the system to accommodate these changes. Maintain simplicity. Focus on simplicity in both the software being developed and in the development process. Whenever possible, actively work to eliminate complexity from the system. Problems with Agile methods. It can be difficult to keep the interest of customers who are involved in the process. Team members may be unsuited to the intense involvement that characterize Agile methods. Prioritizing changes can be difficult where there are multiple stakeholders. Maintaining simplicity requires extra work. Contracts may be a problem as with other approaches to iterative development. Plan-driven and Agile development. Plan-driven. A plan-driven approach to software engineering is based around separate development stages with the outputs to be produced at each of these stages planned in advance. Not necessarily waterfall model, plan-driven incrementally development occurs within activities. Iteration occurs within activities. Agile development, specification, design, implementation and testing are interleaved and the outputs from the development process are decided through a process of negotiation during the software development process.